Hello, everyone. Again, I'm Mostapha. You already know. Thank you for the great introduction. I'm going today to talk about freedom and flexibility to model real-world complexity. It's kind of like an umbrella topic on top of the overall conversation about collaboration in the industry. And when I say industry, I mean AEC industry, architecture, engineering, and construction. And I'll cover it based on pollination, which is a new product that we have been developing now for about 3 years, and is early to the market, and also Ladybug tools. And I talk about it in the context of environmental building design. So if you don't know about Ladybug tools is a collection of tools for environmental building design. We have Ladybug, Honeybee, Butterfly, Dragonfly, and Spider. They work in different stages of design in a way, and they cover different topics. What makes them interesting is they all work together. You can go from Ladybug to Honeybee, from Honeybee to Butterfly to Dragonfly using the same platform. And that's something that we're really interested in because of this. So if you click here, if you talk to a client or you have a business meeting, people like to see the design process like this. You want to say, oh, we start with climate analysis, and then we do massing study. So let's look at Ladybug. Then we move to Honeybee, and we do daylight study, and then we do energy analysis. And then at this point, design is done, and we do some airflow, and everything is going to be great, and everything is done on time. And it's not how it is. So the way it works is like this, right? You just start the process, then you have a question of, oh, we want to put an atrium here. Does it make sense to put an atrium here? And then when you talk about something like an atrium, it's daylight, it's airflow, it's heating, cooling, all of this comes together. And then you're like, how do I model this? And people will tell you, oh, actually, the airflow doesn't do that. You need something that doesn't airflow. So you start a project just needing the CFD, which if you go back to this diagram was supposed to happen at the end of the project. So the challenge is how do you design for this level of complexity, right? How do you design the tools that people can use at any step of the design and kind of evolves with you as the design evolves? And that's where pollination comes in. So this is a chart that shows the process of the project. I released Ladybug in 2013, and then Honeybee came after that, and then we had Honeybee for daylighting energy, then Ladybug to the subject become a thing. Dragonfly, Butterfly, I changed a lot of jobs, as you heard during the introduction. And finally, in 2018 was the time that we started developing pollination. And I'm going to talk about why we did that. And I want to thank the Department of Energy because we actually got a grant from the Department of Energy, which paid for most of the development of pollination and made it possible for us to work on pollination. So what's pollination? What does it? How does it work? What makes pollination, and why do you need pollination, and how to get started using pollination if you're interested. So that's the topic. So pollination is an ecosystem of tools for environmental building design and simulation. This is very similar to Ladybug tools in a way. And what it tries to do, it tries to get you from question to actionable data quickly. And one thing that I want to emphasize here, it's very important to everything that we develop for Ladybug tools, as well as when we develop in pollination. And I hope it can be, if I give you one thing during this presentation, I want that to be this. The place to go from question to actionable data is not like this. If you see something like this, someone is hiding the complexity of the question from you. Reality is like this. You have a question, you do the first round of study simulation change to get to some initial data. This initial data helps you to have informed question. And when you ask an informed question, that's when you get to actionable data. One of the patterns that we see more and more as technology makes it easier to develop tools is the first one that I showed. It's just like, oh, you have a question, we have a tool for you. Just click here, we give you an answer right away. You don't need to think. You don't need even to know what's your question. That's like fast food, It's like you're hungry and they're giving you fast food. And fast food is good if you eat once a month, or I don't know, probably every 3 months. But if your diet is on fast food, you're going to end up in hospital. If you design your buildings based on fast food strategies, based on this is cheap and quick and just get me what I want without having me think, then you're missing something. And the challenge with buildings is when you get it wrong And when you know it's wrong, it's really too late to go back and fix it. We all know that famous diagram of like, you know, oh, as part of design grade, we can make decisions. So it's challenging. It's not supposed to be easy. It's not meant to be easy. It's meant to be easy to start, but it doesn't meant to be easy all the way. Yeah, that's all. That was my presentation. So, no, I have more. So that one, then we started talking to a lot of offices and practitioners to see like what's the problem with workflow? Because one of the other things that you talk to people just like, oh, we don't have time, everything like we are under budget, we don't have all these things, we can't work, you know, and then you just start talking to them and they're like, what do you want? You're like, we want simulation to be real time. And we're like, okay, we give you real time. Is it like really your problem? Let's just like how we work. So you have architect on the top here, you have engineer consulting here in the bottom. Then there's deadline, right? And everyone is happy on that kickoff meeting of like, oh, we're going to do this project, it's going to be the best project we have done ever. And the engineering side, the consultant side goes away and says, oh, send me your design option and I'll just run the studies for you, right? And you just wait and they send you a study. They say, like, this is our first option. Can you test it for us? And the first study, and I have been fortunate to work on both sides of this as an architect, as a consultant. They have seen how it goes. So they send you a model, and guess what? The model is like a huge Revit file with all this data that you don't need to run any studies. And you are out, I'm here now, like, you know, someone tells me something. And if you could go back and you just like, oh, sorry, like we just got your model, we're working on it, which basically means we're just remodeling everything that you have. People rebuild everything because they can't use your design model because your design model wasn't designed to be used for analysis. And then run your analysis. So that small part that you see here, this is the real-time simulation that people want. So all this time is not about the simulation itself. It's about to get to the point that you can run the simulation, or the person who is responsible be able to run the simulation. They send it back, and this is what we call a 2-week gap. So there is between 2 to 4 weeks gap between the time that you have a question right now and a consultant or a person tries to give you answer to that question. And as designers here, who are most of you, you know what happens during that time. The design changes. So basically, they send you an answer for a design that you had 2 weeks ago or a month ago, and now you have a deadline coming up. And what are you going to do? You're just going to put those results in your report because you don't have time to redo it. And then this is what I call environmental Photoshop, which basically you put some colorful images in your report and you say, we are working on it, we will redo it, and you're lying because you don't have time to redo it, right? It's just like waste of time and energy and everything. And you know, there is another model that comes in the middle of this process, you just ignore it because you don't have time for changing. And I say this, honestly, these people on two sides, if you go with them, go out, like have some tea, food, something, everyone gets along. When they work like this, people start to dislike each other. And my thing has been, it's not about people, it's just about the process. The process is broken, makes you unlike each other. So how do we want to solve this? So the way we want to solve this with Pollination is, Pollination stands in the middle as a web-based platform that allows you to interact via using web technology. It's just like all the other technologies that you use that are web-based. You don't need that person to be there to do that. So the difference here is you develop a recipe, a solution, and deploy it to Pollination. This recipe can be something like daylight study, right? Energy simulation, or it can be as complicated as like optimizing something for a specific design. The difference is when the person wants to use it, they don't need you. You just go to Pollination and use the technology, right? And then you have this feedback of like, okay, now I'm done. Can you make these changes? You have version 4.2. This is like every other software that you use on your phone. Right, like they release new versions you don't even know, they make it better, you get updates, and through the process, while you're working, you don't talk to the developer, right? You just get the right tool and use it the right way. This gives you the extra time here. It makes it easy for people to go on vacation without the need to just like break the whole process. So that's what we're trying to do in a very high level. To do that, we had to develop 5 different technologies. Let's start with the chat plugins, then we have recipes, then we have apps, then we have cloud computing, and we have web interface. So up to here, I'm going very slow pace. I'm going to go faster. And again, like if you have any questions at any time, just like raise your hand, we can have a conversation. So the way these things work together and why we had to develop 5 different technologies is because This is a technology that we have a desktop on one side and we have cloud on the other side. So on the cloud computing side, the first thing that we have is all the technologies that are available from the web. And then we have the plugins on the desktop side. So it comes with cloud computing. We have a repository of solutions. You can think about it like apps. So on your phone, when you go on your phone, you go to Apple Store or you go to, what is it called, the other Play Store. You go to that environment, there are like several apps that you can choose and you can use, right? You don't write your own app every time. Then we have projects and galleries, which are the ones that can help you in the web interface for project management. And on this side, we have 3 plugins for now. We have the Revit plugin, the Rhino plugin, and the Grasshopper plugin, and I'll talk about every of them and why they're important. The Grasshopper plugin works with Ladybug tools, so if you're a Ladybug tools user already, Polynesian makes you capable to use all this cloud technology with like 2 extra components, which is magical. And then you have the apps in the middle that connects all this technology together. I'll show apps, but as like in any other ecosystem, I think that's what's important about Polynesian and Ladybug tools and all the tools that we're developing, is it's an open ecosystem. You don't rely on us to be able to solve your problem. So on one side, we have export to all these tools. So if you want to use our tool just to create your geometry and then go use any of this software, you can do that. And we support that happily. Excuse me. And if you have a third-party app that wants to take advantage of Polynesian, you can use our API and everything should work. So how does it work? In a very simple process is you prepare your model, you select existing recipe, you run the simulation, and you visualize the result. And all of this, you see, like I have a gray one here, which means like you can do that or you can do something else. But I'm not going to go through that much detail right now unless someone has any questions. I'm going to go and overview all these technologies for you and try to talk about why they are important and why we had to develop them. So I started with Polynesian CAD plugins, Grasshopper, Rhino, and Revit. You have the Revit plugin. The main reason for the Revit plugin, and again, I don't know how many of you had to deal with this, but from Revit, if you export a GPXML, which is an analytic model, this is what you get. If Polynesian, this is what you get. And this was very important. So if you want to have a good level of interoperability, you should be able to get a high quality model out of your analytical model. The other thing is you have to be able to quality check your model inside the environment before running the study. If you run a simulation and you don't see your analytical model, you don't know if you're running it for the right model. Take this from me. If you run something and it just gives you result, you should be really skeptical about like what's going on under the hood. Then you need different levels of abstraction to be useful. So what we do, we give you a massing model. So this is good for low studies. We give you a little bit more detail if you want, and we give you a full detailed model. Again, the reason you need these 3 different levels of abstraction is depending on the design process, you may not have time to clean the model to this level. You can get a lot of answers that you have right there. And finally, validation as part of the process. So this is a concept that unfortunately in our tools is not very common, but we are trying to make it common. So every step of the process, there's a validation command. If your model is not valid, you have to fix it. If your model is valid, then the thing should run. So if it's valid and it doesn't run, it's on us. We'll fix it for you. If it's not valid, it's your responsibility to fix it. This is also very important because in practice, now we have this moment of like everyone says, like, it's your fault, it's your fault, right? Oh, your model wasn't clean. And they're like, that's not my responsibility. You didn't clean it up the way you wanted. You never told me. So this is going to solve that. And this is important because contractually, I can say, if you give me a valid model, I give you the result in this many days. And that changes a lot of things around. Then we have the Rhino plugin. The Rhino plugin is there because it gives you the highest level of flexibility to edit your model, fix your model. You can build very large models with no issues. You can debug your models. We even have this command that shows you where inside your model potentially will be a problem without you running a simulation. Because one of the other issues that we have is just like you don't know your model is wrong until you prepare everything, you run everything, and you just, oh, it crashed. Now let's go back and see what was wrong. So instead of that, before running the simulation, you can basically run this command. I'm very sorry. And it shows you where the problem is. And of course, we have commands to fix them automatically for you. And we have an API. Anyone here codes? How many of you know Python? Okay, Not that many one. Okay, yeah. If you learn scripting, these tools, you can basically automate a lot of your work. People think when you automate stuff, you put yourself out of job. It's not true. When you automate your work, you can basically get more jobs, right? And you can do more interesting jobs. So you can automate all the boring steps of the process. This is a script that basically changes the window to wall ratio for the building based on orientation. Excuse me. This is a case study just to show you, like I'll show like single boxes and small models, but this is a real building with more than 600 rooms that's modeled with population in about 3 hours. This usually takes like 3-4 days to model with other tools. I think that's the value proposition. The other value proposition is because of all this visualization that we do here, you can quality check your model and you can see the problems before they become a huge problem. This is another model again, like you see they're rendered based on different type of surface that they have. And then finally, we have the grasshopper plugin. And every time as I cough, I want to say I'm very sorry, but I don't do that, okay? You know that, I'm sorry. So the grasshopper plugin, the reason for grasshopper plugin is basically allows you to run parametric studies in Sail, so you can run like hundreds or thousands of studies if you need for different iterations. You can also share your workflow. So this is one of the concepts that we're working on a lot. Is even if you use Grasshopper, one of the challenges that we have seen in the offices is like you have a Grasshopper script and someone else has the same Grasshopper script, but they're not the same, they're similar. And Grasshopper is not a platform that people can work together. So the problem that happens is you have a thing that you ran 2 months ago, you get a new project, you want to run it, it doesn't run, or it gives you a different result, or something has changed that you didn't know and it's just broken. So with this system that we have, now everything is like a package. So there is one place and you go inside Grasshopper and you say, give me that recipe, and it just loads the recipe from there. So you always know you're getting the same thing. Why is it important? Because it means if your simulation runs now, it will run in 6 months, if you're running 1 year, it will run forever. Because everything is versioned and everything works together. And the same thing here is like, because of the whole system is on the cloud, now you can load the result from anywhere. So you don't need to be on the same machine to check the result. This means like if you're working in an office and you have a more junior person who runs the study and you have a more senior person who wants to check the results of the study, they don't need to use the same machine. One person runs it, the other person can load it from inside Grasshopper without having anything from that model. And of course, everything can happen from inside the CAP plugins. You don't have to go. So that was the CAP plugins, and then on top of that, we have a web-based platform, which is Pollination. So the web-based platform, the one that people like the most is about scaling up. So this is a daylight simulation. Now you see like it's running on 3 machines, and then it scales up to like thousands of machines running. So every single circle that you see there is like a computer that pops up to run the simulation, which helps you run larger models faster, of course. I like this animation, so let's watch it again. Yep. Pops up. And then you can do real-time collaboration. Because of all this concept, you have the concept of team. You know, instead of having all these files on someone else's computer that you don't know who has what, everything is on the web, you can go and access them. Then next one is like, again, as we do in Ladybug, we do the same Pollination. All the code of the simulation that we use is open, so you can go and see them. If you know, you can edit them. You can make sure you're running the right study is for you and is cracked. And finally, we also support things to run on cloud, and we support them to run on desktop. And this is part of what I talk about complexity, right? Servers go down. Like running things on cloud is not necessarily affordable. They can get really expensive. Sometimes because of privacy, you cannot run on cloud. So in Pollination products, you can just switch the run between cloud and desktop simply, and the same thing that runs on cloud runs locally on your machine. So what are our principal guidelines? Why we did make these decisions? And some of them, you know, a little bit are against, I mean, you guys use Autodesk products, so you know how it goes, right? You want to get people in and you don't want them to leave. So why do I allow you to run things locally? I'm going to lose money, right? If I want to make most of the money, I should just keep everything on cloud. But and this is like a very hard decision, especially for a small company. How do you make those decisions? And I think we have 4 values for automation, customization, collaboration, and democratization. There is a link here that you cannot see, which is principles of pollination if you want to find it online and read more. But I'm going to go over some basic ones. So one is acknowledge that the real world problems are inherently complex. Like any problem that we have in the real world, they're a complex problem. And it's not because of geometry, right? It's about, like I just showed you, it's about like knowledge. The different part of the project, they have different part of the knowledge. And this collaboration, and at the right time, we need to have access to the right information to make the right decision before it's too late. The other thing is the real world is imperfect. Even if you educate everyone in your office, design any standard that you have, at the end of the day, your models are not perfect. There will be bugs in it. There will be faces that don't meet. Just be ready for that, design for that. And then there is no such a thing as one size fits all. I think that's the problem that, again, I say over and over, that I see, especially in architecture, we see a lot that people want very easy solutions. And they want single solutions for everything. There is no such a thing, at least I think. And your question will evolve over time, so should your process. We think like we have the same question, like, oh, what about this? Next day, your question is going to be different based on client, based on location, based on design, and that's what makes design interesting. So you should pick the tools that can do that. They can evolve with your process, and then customization and education comes before automation. If you have a tool which is automated and you cannot customize it, you're probably automating a problem which is not your problem. If you can customize the solution for your problem, you're running something for some other building. I see that people, oh, I just did this, I ran it, no errors, this gave me this number. I'm like, this is a good number, but this is not for your building. This is for something else which was abstracted that you didn't know. And this is another thing that we have. The other value proposition that we try to bring by pollination, and I think it's important, is because of all these different tools that we use during the design process, for good reason, a lot of time we have solutions for a specific tool. So for example, like just Ladybug tools, it runs only inside Grasshopper and Rhino. So if you're not a Grasshopper Rhino user, usually you have a very hard time to use them. In pollination, we're changing this. Now you write it once and use it ever. So you can use it locally, as I said, you run it, it runs locally, and you can quickly, within minutes, deploy to cloud so everyone can use it. You go from like a local development to production level. This is a Daylight Factors recipe that runs Daylight Factor. I'm going to show you like the same recipe, how does it look like with different tools. So this is how it looks like if you run it from web. So if you go to publish in the cloud and you want to run it, it says select the project, select your model, what's the grid filter, put radians, run it. If you go inside Rhino, this is the same exact recipe. Shows up in Rhino. The thing that happened here, the module is linked, all the inputs are the same. This is how it looks like inside Grasshopper. So it looks like a Grasshopper component. This is how it looks like inside Revit. So it's a menu inside Revit, which is linked to your Revit module. And this is how it looks like when you run it from desktop. So what we're doing here is instead of writing 5, 6 different codes for 5, 6 different platforms, we are writing the code once. It's on pollination, it's on the web, and then we have different interfaces, so you can use it from everywhere. I don't know how clear is that. At least the problem that we're solving is this. Like person A has a Grasshopper script, person B has a Grasshopper script, person C has a Grasshopper script, and they all think this is the same Grasshopper script. It's not the same Grasshopper script because you changed it during the project and you don't remember what you changed. That's fine, we all do that. And now, instead of that, we'll get this. So all these people have the same recipe that they can use from all the tools that they like. You don't have to use it from inside Grasshopper anymore. So if you're comfortable using it inside Revit, you can just use it from inside Revit and you get the same level of accuracy. And I didn't see that many people know Python here, but if you're interested, we already have more than 20 recipes that you're going to start hacking and learning how to do those stuff. I talked about this already, so I'm not going to spend a lot of time on this, but it's cloud first, but it's not cloud only. You can run the same simulation locally, and we treat all the local runs and the runs on pollination basically the same. They're both valid simulation, And this is the one on Grasshopper that shows like, I just changed this can change to the desktop, now I can run it locally. Validation as a feature, again, I talked about this, a reminder, validation is part of the process. So if you want to do something like this is the Revit plugin, this is all the formats that you can input, this is all the formats that you can export to. If you want this to work, you should have validation at any step. One of the things that we see is like, and I talk with a lot of mechanical engineers and consultants, and they're like, you use any design model? They're like, no, never. It's just useless. I'm just, why is it useless? Because they say if we redraw everything, we know what we get. If you use design model, nothing works. And this is a lot of reworking and redrawing, and I just showed you what's the problem. So with this validation as part of the process, we know at any point of the process that this is a model that you can rely on, and you can really have the collaboration. This is an example that we wrote exporter from Holland to IES. Do you use IES here in Turkey for simulation? Okay, limited. But yeah, IES is a great software for simulation, but it has a very clunky interface for drawing geometry. So it basically does this in just a few seconds if you have a model, valid model inside. IES. We also have an import. I'm not going to show this video. And now we also have an export, for example, to eQuest. So one of the things that we're trying to do is we're trying to help everyone to work in the software that they're good at, you know, and then use the same logic, use the same, what we call schema to make this possible. It's similar to how with the phone, this is a very, I think, very normal concept. Now we all know that. Like if you have an iPhone versus if you have an Android, a lot of things that you're using are the same apps. It's not like if you want to have a calendar, you should have an Android. Or I know like iPhone is still like their thing, but this is a similar concept. If you want to use, to be part of energy modeling or ethical modeling, you shouldn't be in a software. You should use the software that you're more comfortable with and be responsible to make sure you can get there easily. And this is a little bit technical because no more codes here. It's okay. It's just like there are reasons that it works. And then one of the other things that we have seen a lot is when we work, again, like we use different software. Do whatever you want. Others can say whatever they want about Revit, that there is no single model. There will never be a single model. I wrote it down and signed. It's not going to happen because the people who build those models, they don't have the knowledge to make the model useful for everything. That's not going to happen. I don't know, like, at least anytime soon. Because of that, we know there will be different tracks. There will be a design track, there will be an analysis track. So how do you solve the problem that while the analysis track is working, the design model is changing, right? So you have an original model, they add construction, they add program, and then you have a new design iteration. So what do you do then? In a normal workflow, what really happens is you send a new model, the consultant side, everyone is just like, oh my God, all the work that we did is basically not published, let's start again. But now with pollination, and this is something which is very normal in software development. When you do software development, you have a new code change, you basically review the code and you merge it in. You don't rewrite the whole code, you don't erase the whole code. So what if we could do that with the same, with our architectural design model, the environmental design model? So this is what you can do here. This is an example that you have a model. This color blue means they don't have any program. And then you get a new model from consultant, it comes in, and now you can see there's the pop-up that basically says the model is valid. And then here I can check and I can see what are the changes that happens, which rooms have changed, what has changed in those rooms, is it only geometry, is it metadata? And I can say merge all those information inside without changing the geometry. So now you see, instead of me like removing all my work, now I have an updated model that's in sync with the analytical model, right? Without losing any of my work. This is another example which is different. Now the geometry is changing. I mean, I don't think there is, yeah, let's, how much time do we have? Okay, let me go a little bit faster. This one is basically, now you can see there is a new room. I basically select the new room and I say merge it. And it merges it, and now I have two rooms there, but the rest of the geometry and all my work is going to be there. And finally, encouraging your way, not our way. This is what happens during the software development. So when you start, everything is exciting, but at some point, you have to keep your core product to itself. You can't change it because everything is high risk, right? When I have thousands of users using a feature, If you come to me and say, I want this thing to change, I can't change it because I have to be responsible for thousands of users. And then this will be your needs, this will be the core product, and this will be a gap. And there are different tools in the market that actually do this very good and very bad. So the Rhino Grasshopper side of thing, it has been very successful to allow people to do custom scripted apps like Ladybug tools. And those are the things that basically bridges this gap. So you can use the tool, they don't need to change the core product, and the user can get what they need. And this is what we are trying to do with all our tools. So this is an example, again, like you can write a quick script with like 5-6 lines, and you get a takeout from your Rhino model. I know like in Revit, you can generate the schedules, but you have control on what you want to do. This I already showed, which is window to bar ratio. And finally, when we're taking this is the end of the presentation, is we start thinking, okay, if you have all this stuff, right? If we do all this, we're still asking people to do things from inside CAD plugins, which is okay. But what if we can develop a technology, a web-based technology that people can also use from CAD, so we can bring everything that we have done together in a way of like you have one app. It's similar again, as I said, as your phone app. You can use it on your phone, you can use it on your iPad, you can use it on your tablet, you can use it on your desktop. And this is the same tool. And based on where you're using it, the interface is a little bit different. The functionalities are a little bit different, but it's the same tool. So pollination on one side. There is another technology in the market called the Streamlit. The Streamlit is not developed by us. It's an open source project. They just recently they were acquired by a company called Snowflake. A very successful project. So what we are trying to do, we're trying to make building simulation easy and accessible. What they're trying to do is making building data apps easy. So if you bring this together, we can basically making building simulation apps easy. What does that mean? It means now, on top of all the libraries, APIs, plugins, everything that we have developed, you can develop the scripts in hours or days. So if you wanted to develop a plugin, it will take you a day to weeks. API takes months to years. Library is not even talking about it. Like it takes years to develop a library that you can use. Now with these apps, we hope you guys can, by learning a little bit of Python or hacking a little of other people's code, excuse me, do this stuff in hours to days. This is how it works. It's very similar. This is, you already know this because this is how you use your phone. You have developers on one side, you have users on the other side. What we do with automation, we allow you to package, the developers to package their technology, push it there, and we bring it to you inside an interface that you can use it from the CAD plugins or you can use it from the web. This is how the app goes together. I'm not going to spend time on this because it's very technical, but the point is, because we have a small layer of inputs and outputs here, it makes the app look native from a CAD plugin. And I'm going to show you that. Again, going back to the first slide that I showed, this means if you have other services like, Rhino Compute, Macbox, SuScale, you can also use them as part of pollination because it's a web-based technology, right? You can use all these technologies that are available out there. You can use all the technologies that we have developed. You can build an app that works from any of these platforms in a few hours. So this is a website. I mean, I don't have my laptop to show you a live demo. But if you go right now to pollination.gallery, you will see this. You will see a few apps like this. And if you click, for example, on this SongMap app, you will see a SongMap app in your phone that you can play with. Or you can play with the Context 3D app, which brings the Context 3D. And that's interesting. But what's more interesting is you can load that same app from inside Rhino. So this is Rhino. And inside Rhino, what I can do, this is a GIS app. I can go and load the whole context from the web. And the good thing about web is like there are so many technologies like this already available. And I can translate that from the web into Rhino. So it looks like a native Rhino plugin, right? I can make it if I want. And then I can go and say, okay, now that I have this, so I have to wait a little bit here. But now I can go to the next app that I have and run direct selling study. So in this one, basically the same UI, no grasshopper, no spaghetti thing that I know people freak out. And this is like a normal web that everyone knows how to use. So you just prepare the model, you run the simulation, And here you go, you have the results. The results are running on the web, but they're visualizing your CAD platform, and it gets more interesting when you know that you can actually bake that result inside Rhino. So now they're part of your Rhino document. So no more of this thing of, look, this is my Rhino file, this is my Grasshopper file, and sorry, they're out of sync, I don't know. So now all your analysis, all your data is part of your Rhino document. You basically save your Rhino file, you send it to someone else, they have access to all the analysis that you have done, and you save in your file. And this is, I think, like this just shows a little bit of like, we give you the full control that we give you in Ladybug tools to run all the stuff, or to visualize everything the way that you like to do. This is another thing to show, like in the other example, we ran the study inside the app, what we call, or you ran it locally. So once you close the app, you don't have the results. But if this is a simulation that you want to keep the result, you can also run it on Pollination Cloud. And when you run it on Pollination Cloud, it looks like this. So you can go there, oops, and click here. You can go there, and basically you can see how the simulation is running, and everyone else can also go and see it. And if you want, all the links are here. You can go to pollination.cloud or go to app.pollination.cloud, and you can see it all. They're all accessible as we talk today. This is another example. And this example shows, this is more for engineers of like when you want to do a study and you want to build a base model, what we call, or geometry generator. This is an app that you can quickly create your model and bake it. So instead of spending any time modeling this, you basically get this model for free with a few clicks. What can get really interesting is now you can bring other web-based apps and make the CAD plugins without any like extra coding. So this is a technology called Architext. This is developed by a good friend of mine, Theodore Galanis, and as his PhD. So what he does is you just write there an apartment with 2 bathrooms or whatever, and it generates a plan for you. So this is a web-based. If you search for Architext, you can find it. So the challenge that he had was like, okay, I have this, but I want people to be able to continue working on this. And that's where Pollination came in. We said like we can easily make that model be a Rhino plugin. So what we did, we basically added a few line of code. We added 3D viewer, we added more controls. So here I'm changing the window to our ratio. I know this is not a great design, but you can imagine as this artificial intelligence becomes better and we can generate better buildings, it's really important that all these platforms are connected. So now as soon as you have the model generated, you have the model in Rhino, and the same can work in Revit. So the time between generation and documentation is just like gone, right? When you have something generated, you basically can have it documented. And this is another example that we use. This is a photovoltaic company or agrivoltaic that they do agriculture photovoltaic, and they wanted an app that they can show to their clients so you can go there and they can go and see what's the average monthly irradiance, and they can basically make a decision. So one of the other things that you can do with the app, if you have a client and you run different types of studies, you can basically deploy to the web and say, these are the things that we ran, this is the 5 options that we have, so you can explore them and you can give us feedback. And yes, for all the SketchUp people here, we are also working on a SketchUp. I know we do all this presentation, people are like, what was the SketchUp? Well, like, here's a SketchUp. So the video is not working, but believe me, there is a SketchUp. Come on, the SketchUp. Yeah, this is the SketchUp. So because the integration layer is very small, right? The whole core core logic is developed outside the CAD plugins. It's quite easy for us to add more platforms. So what really happens here, we are using OpenStudio in this case. But now this model in OpenStudio, you can see there's a pollination icon there. At some point, we click. Here you go. And now you can load that model inside SketchUp. This is a prototype, so we're still working on it, but you can see like the model basically now doesn't matter where you are, you can run the same studies and you can use the same technology on that. Okay, so if you are interested, we can start today. All the technologies that I showed are available right now in the market. You can go and download it. For all of them, we have considered a free way of using it. I mean, that's by design. So you don't have to worry about being behind a paywall. And I go through a list of what to use at what level, but I'm not going to go through this here. And upcoming features are, we are working to make the apps easier to deploy if anyone is interested. I think one of the most important part of the whole projects that we do is we count on you. We count on people to learn and develop what they need with our help. We built all the platforms. So when I was in school, like now years ago, 20 years ago, and I wanted to do any of this, I had to start developing from scratch. And that's what I did, right? I had to start from like zero, like there was nothing, right? You have to do all this stuff. And by the time that you wanted to do that, everyone would tell you like, what are you doing? Where is your design, right? Because like you have to do other stuff. Now, thanks to the technologies, if you want to do something different, if you have a design process that you want to explore, it can take you minutes, right? If you don't know anything, maybe it can take you weeks to learn. But it's much, much easier. And I think that the whole passion, the reason I do this, because I want to empower people like you to be able to do this stuff, right? I don't want this to be limited to some large companies that you have to pay a lot of money to access that, because really our buildings are really bad. They're poorly built, they're poorly designed, and we want to fix that. And I think technology is there to help us. But technology is not going to solve our problem by itself, right? You are the one who is going to solve this problem. And I hope these technologies can help you to do that. Apps are something that I'm very excited about, and I hope like makes it easier for more people to contribute and do better. We are going to roll out that integration with Revit for all the Revit users, and we will develop more based on like your feedback. We are, again, like we are back. We come from an open source development way. The way we do it is with community, and there is no, you don't have to be in the same level or you just pay for something. So if you go to publish.community, you can share your thoughts. We listen to everyone. You can get involved. We'll be happy to help you. I'll actively check the forum. And yeah, I hope you get something out of this presentation. That's all I have. Thank you.